7.6, the vertex form of a quadratic function. So the vertex form of a quadratic function is written in this form: y equals a, x minus h squared plus k. In this form, the vertex can be located easily by the values of h and k, and just happens to be at the point h comma k, only if it's written in x minus h plus k, only if it's written in this form. And you have to make sure that the squared is on the outside of the brackets. Notice that it's minus h and plus k. So as long as it's minus h plus k, your vertex is just at h comma k. Otherwise, it's going to change. If it's plus h, it's going to be at negative h comma k. If it's plus h minus k, it's going to be negative h negative k. Let's see how this works. All right, so quick. Where's the vertex and the axis of symmetry? So here it's minus h plus k. So my vertex is going to be at 2, 1. 2, 1, x, y. Remember that your axis of symmetry cuts it right in half and cuts right through the vertex. So your axis of symmetry is actually going to be at x equals 2. It's always just the value of your x coordinate. So negative 2, 2, plus 1, 1. Now, where's the vertex on this one? What do you think? Well, it's plus 3 minus 4. Okay, plus 3, so that's going to be negative 3, and minus 4, negative 4. So the only one that changes is the one inside brackets. The only one that changes to negative or positive is the one inside brackets. And the axis of symmetry is, again, x equals negative 3. All right, now where's the vertex of this one? Okay, I got x plus 4. Okay, so I know that's negative 4. And negative 5. Minus 5. Good. Okay, axis of symmetry. Again, just your x value of your coordinate. So x equals negative 4. So, really easy. Your vertex is located at the h comma k value. If it's plus h, it's going to be negative. If it's minus h, it's going to be positive. So just some things to think about there. Alright, so why would we ever want to do this? Well, there's a quick method to graph without using a graphing calculator. Back when I was in grade 11 and 12, we were not allowed to use a graphing calculator. They weren't really available. When I was in grade 12, we had them, but we weren't really allowed to use them in grade 11. So how would we graph these? Okay, first thing I need is the vertex, which is at 3, negative 2. So that's the first thing I start with. 1, 2, 3, negative 2. It opens, well, it's a positive value, so it opens up. The axis of symmetry is at x equals 3. Right? Just your x values. So your axis of symmetry cuts through here. So I know across that axis it's going to be symmetrical. How do these work? How does any quadratic work? Well, if you think about y equals x squared, and you're plugging values into x, if I plug the value of 1 into x, I get a value of 1. Negative 1, I get a value of 1. If I plug a 2 into x, I get a value of 4. Negative 2 into x, I get a value of 4. How does that translate onto a graph? Well, if I plug a 1 into x, that's like going over 1 along the horizontal. If I'm getting a 1 out for my y, that means I'm going up 1. So I go over 1, up 1. If I plug a negative 1 in, that means I'm going back 1, and I'm getting a 1 out. So I go back 1, up 1. What happens if I put a 2 in? Well, if I plug a 2 in, I get 2 squared, which is 4. So 2 is the same as going from your vertex over 2. That means you're going to be going up 4. 1, 2, 3, 4. Back 2, up 1, 2, 3, 4. And that's all you really need to do in order to graph your quadratic. As long as you have enough points, your vertex and 4 other points, you can graph it. And that's it. It's kind of a fun way to graph because you know there's a kind of a format. Over 1, up 1, over 2, up 4. Back 1, up 1, back 2, up 4. And it's all based on the y equals x squared. What about the value in front? What if a is positive? Well, we know that it opens up. What if a is negative? We know that it opens down. Okay, so opens up means it's going to be like this. Opens down, it's like U and N. Opens down means it's going to be like that. So what if the a value, what if the number in front is greater than 1? This doesn't happen a lot in your assignment, but it does happen for sure. Now, first thing we need to know is the vertex. The vertex is at negative 1, comma 1. Is that right? No, it's at 1, comma 1, right? Because we have minus h. So 1, comma 1. I know that this opens up. So it's going to open up. And I also know the axis of symmetry is at 1. Now, I have a value of 2 in front of for my a. So that would be like this. Let's look at the value of y equals a x squared. In this case, 2x squared. How is that going to affect my over 1 up 1 and over 2 up 4 like I usually do? If there's a value of 2, or whatever your value is, you still plug the same values in for x, so I still go over 1. But what happens? If I square it, I get 1. Then I have to times by 2. So instead of going over 1 up 1, I go over 1 up 2. Back 1 up 2. Remember, it's symmetrical. What happens if I plug a 2 in, though? I still go over 2, because I'm still plugging a 2 into x. So I go over 2. 2 squared is 4. So usually I went over 2 up 4. This time, though, it's going to be over 2 up 8, because 4 times 2 is 8. So everything that you usually did is now doubled. So now it's over 2 up 1, 2, 3, 4, 5, 6, 7, 8, way up here. Okay? And back to up 8. Remember, it's symmetrical. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So your graph is going to look like this. What happened to my graph? It got stretched. It got stretched vertically by 2. Okay? So the value in front, the a value, just changes the amount that you're going to go up. So you still go over 1, but in this case you're going up 2. Because usually you go over 1 up 1. Instead of going over 2 up 4, I go over 2 up 8, because I'm doubling everything. Alright, what if the value in a is less than 1? So I still have the same vertex, 1, comma 1. This time, though, let's think about that. If I have y equals 1/2 x squared, like our normal parabola, then what happens? Instead of going over 1 up 1, this time I'm going to be going over 1 up a half of that. So over 1 up a half. Back 1 up a half. Usually I go over 2 up 4, but this time I'm going to be going over 2 up a half of 4. So over 2 up 2. And over 2 up 2. Symmetrical. Oops. So this time what's happened to my graph? Well, it's actually been squished. It's been squished vertically by 1/2. So notice what happens with the a value. It either gets stretched if the value is bigger than 1, or if the value is less than 1, like a fraction, it gets squished. It still opens up because my value is positive. It would open down if my value is negative. And that is how to graph using the a value and also using my vertex and my axis of symmetry.